Chapter 8.2, Trigonometric Ratios. Today, by the end of the video, you will know how to find the sine, cosine, and tangent of an acute angle. So trigonometric ratios, I say trig instead because it's shorter and I'm lazy. So trig ratios, there are 3 trig ratios, sine, cosine, and tangent. And what a trig ratio is it just compares side lengths in right triangles. Okay, so if we think about a right triangle here, and I tell you that this right triangle, we'll call this side A, B, C, and I tell you that this is a 30-degree angle, and then I give you another triangle, and I'll call it D, E, F, and I say it's also a right triangle, and it's 30 degrees. Well, because these 2 triangles have the same angle, they're similar to each other, and so that means every single right triangle with a 30 degrees will have proportional sides. So I could draw another one that has 30 degrees and it would also be proportional. So because all we need to know is this angle, we've created trigonometric ratios. Because again, we're just comparing the side lengths to these triangles, and they're always going to be proportional. So sine, cosine, and tangent are 3 trig ratios, and they compare different sides. The sine compares the opposite side to the hypotenuse. So if you look at angle A, and I wanted to figure out what's the proportion of the side opposite to hypotenuse, we would say that that's A over C. So for sine, it compares the opposite to the hypotenuse. Again, it's just comparing side lengths in right triangles. Cosine, instead of comparing the opposite side to the hypotenuse, it'll compare the adjacent side to the hypotenuse. And adjacent side means right next to but not touching. So if I wanted to find out what's the cosine of A, that's really saying what's the side length of the side adjacent, which means it's touching and it's a leg, so it can't be the hypotenuse over the hypotenuse. So that's how they got B over C. Again, I want you to write down the adjacent cannot be the hypotenuse. They will be different numbers. And then tangent, let's see, we have opposite over hypotenuse, we have adjacent over hypotenuse. The only other way we can talk about it is the opposite over adjacent. So if I wanted to know what's the tangent of angle A, tan angle A is opposite, so opposite means it's across from, not touching, that would be A, to the adjacent. And again, it's not the hypotenuse, so it would be A over B. Okay, now if you look at this, again, sine, cosine, tangent are just comparing side lengths in right triangles. And an easy way to remember it is this thing called SOH CA TOA. And the O stands for opposite, and the H stands for hypotenuse. The A stands for adjacent. And this, if you remember this saying, SOH CA TOA, you'll remember that sine always stands for opposite over hypotenuse, cosine always adjacent over hypotenuse, and tangent always opposite over adjacent. So the first thing you're going to do tonight is just write down the fraction and decimal answer for these trig ratios. So here's a triangle, triangle JKL, and I want to know what's the sine of J. So this tells you what angle to look from. So I'm looking in correspondence to angle J, and I know sine stands for opposite over hypotenuse. So the opposite would be side 20, I'm sorry, 60, and then the hypotenuse is always across from the right angle, so that would be 61. So that's your fraction answer. To get it as a decimal, just pop it into your calculator. Cosine J, cosine stands for adjacent over hypotenuse. So cosine J is, we already know that the hypotenuse is 61. We already knew that the 60 was the opposite, so that means 11 has to be adjacent. It's right next to J. It's touching J, so that's 11 over 61. And again, to get the decimal answer, just pop that into your calculator. The last one, tangent. Tangent stands for opposite over adjacent. We know opposite is 60. We know adjacent is 11. So these are the proportions, the ratios that compare the side lengths. So that's for side J. I'll do one more with you. And then you're going to do 7 through 12 on your own. And I will check tomorrow in class. Okay, so if you notice 4, 5, and 6 are all talking about angle K. So now, according to, in respect to angle K, 11 is going to be the opposite. 60 is going to be the adjacent because it's touching it. 61 is also touching it, but it's across from the 90 degrees, so this is the hypotenuse. Okay, so sine stands for opposite over hypotenuse. So opposite is 11, hypotenuse is 61. So that's your answer for number 4. Number 5, cosine stands for adjacent over hypotenuse. So adjacent is 60, hypotenuse is 61. And then tangent is opposite over adjacent. So 11 over 60. All right. So those are your answers. You're done with those questions. Go ahead and do 7 through 12. And again, I'll check that tomorrow. And then the last one, it says using trig ratios and special right triangles. So if you notice, this is a 30, 60, 90 triangle, and here are the shortcuts that we learned last chapter. And they want you to find cosine of 30 degrees. So this is telling you what angle to look from. And you know cosine stands for adjacent over hypotenuse. So in respect to the 30 degrees, we know that this side would be opposite. This is across from the 90 degrees, so it's always going to be the hypotenuse. So this one has to be adjacent. So if you just fill that in, adjacent is s radical 3, and the hypotenuse is 2s. And then all you have to do is simplify. The s's cross out, so your answer is radical 3 over 2. The cool thing about this one is that that means in every single 30, 60, 90 triangles, every single one, cosine will always be radical 3 over 2. And this will help you guys out in pre-calc and calc. So try to do number 14, and then answer the reflection question, and I will check this tomorrow in class. That's how reflect and remind yourself what a trigonometric ratio is.